is vector B in the span of matrix A? So here we have this beautiful 3 by 3 matrix, and we have our vector B. So I want you to recall as we begin that the span, specifically of a matrix A, is the collection of all possible linear combinations of the columns of matrix A. So here we have 3 column vectors, A sub 1, A sub 2, A sub 3. So how do we determine if vector B is in the span of A? Well, we are going to need to row reduce the augmented matrix. So we're going to need to row reduce matrix A augmented with vector B to see if echelon form exists. So here we go. Let's check. So we have our matrix A, which is 1, 2, 3, 1, 2, 3, 1, 2, 3. There's your coefficient matrix. And we're augmenting this with the vector B, defined as 4, 5, 6. Alrighty, so from our first pivot position, we want to use that pivot to eliminate the entries below it. So we need 2 steps here. We will take minus 2 times the first row plus the second row to attain the new second row. And then we also need to eliminate the 3 in row 3. So we'll do minus 3 times the first row plus the third row to attain the new and reduced third row. So here we go. Here is the equivalent matrix. Now the first row remains as it is. We still have 1, 1, 1, 4. So our first row operation is to multiply the first row by negative 2 and add it to the second row. So we are going to have negative 2 plus 2 gives us 0. We'll have negative 2 plus 2 is 0. We'll have negative 2 plus 2 is 0. And last but not least, we have negative 8 plus 5 is minus 3. Stop! This is nonsense. Without even having to go any further, does this make sense? I kind of gave it away, but no, it absolutely does not make sense. Right? We have a contradiction. We know that 0 is never equal to 3, no matter how hard we try. So what is this telling us? Well, since 0 does not equal negative 3, the system is inconsistent. In other words, if a system is inconsistent, no solution exists. And if no solution exists, can vector B ever be a linear combination of the columns of matrix A? No. So we can make our final conclusion here and say, therefore, since the system is inconsistent, we cannot write vector B as a linear combination. And I'll abbreviate linear combo for linear combination of the columns of matrix A and thus vector B is not in the span of A. Or if you want, you could write your span of A as the span of vectors A sub 1, A sub 2, A sub 3. And this is our beautiful final answer. So we cannot write vector B as a linear combination of the columns of matrix A because the system is inconsistent and no solution exists. So therefore, vector B is not in the span of A.